On July 1, 2025, in Rio Hurtado, Chile, the ATLAS telescope, the Asteroid Terrestrial-impact Last Alert System, spotted a tiny speck moving across the stars. At first, it looked like a typical comet, but soon, the observing team noticed something strange: a hyperbolic orbit. Most comets we observe follow closed elliptical orbits, looping around, bound by the sun's gravity. But this object was different. Its orbital eccentricity was over 6, so extreme that its path looked almost like a straight line. It was also moving at 60 kilometers per second, fast enough to circle the entire Earth in just 11 minutes. An extreme orbit, an unimaginable speed. Scientists quickly realized this was an interstellar object. An interstellar object is one that escaped another star system and made its way into ours. But in truth, the odds of observing such an object are incredibly low. Even a 0.01 degree difference in trajectory would translate into tens of millions of kilometers of deviation over its interstellar journey. Humanity has only ever observed 3 such visitors: Oumuamua in 2017, Borisov in 2019, and now this newly discovered object, 3I Atlas. Atlas quickly became one of the hottest topics in astronomy after its discovery. Its rarity as an interstellar object was part of the reason, but what truly drew attention was when it was discovered. Oumuamua and Borisov were both detected only after they had already passed close to the sun. The observation window was brief, and the data collected from them were extremely limited. However, Atlas was spotted much earlier, while it was still beyond Jupiter's orbit, long before approaching the sun. This gave scientists a far longer observation period and a wealth of more diverse data. According to measurements from the Hubble Space Telescope, Atlas's diameter is up to 5.6 kilometers. That makes it likely much larger than Oumuamua, about 200 meters across, or Borisov, roughly 1 kilometer wide. Yet early estimates suggested Atlas could be as large as 10 to 20 kilometers across. That apparent size resulted from Atlas releasing powerful jets of gas, making it appear larger than it actually is. This phenomenon is called a coma, a cloud of gas and dust that erupts from the nucleus and surrounds it like a glowing veil. The coma is then pushed away by solar wind and radiation pressure, forming a tail in the opposite direction. A coma and a tail. These are the hallmark features of a comet. But there are several strange things that make it hard to call Atlas a typical comet. First, the timing of its outgassing. Typical comets don't become active until they're inside Jupiter's orbit, when sunlight begins to vaporize their ice. By contrast, Atlas was already undergoing vigorous outgassing beyond Jupiter's orbit. This suggested that Atlas wasn't primarily composed of water ice, but of far more volatile materials. On August 6th, a spectral analysis by the James Webb Space Telescope revealed that most of the material outgassed by Atlas was carbon dioxide. The proportion was overwhelming, unlike any comet ever observed before. Even more strangely, Atlas's tail, which initially glowed red, recently turned green. Its metal composition was equally strange. The spectrum showed clear traces of nickel, yet not a hint of iron, an element commonly found in comets. In the end, though classified as a comet, Atlas is undeniably an outlier, an object with properties and behavior unlike any comet we've ever known. Professor Avi Loeb of Harvard University paid special attention to Atlas's orbit. Its trajectory skimmed past Mars, Venus, and Jupiter in rapid succession. He said it was hard to call this a mere coincidence. Moreover, at perihelion, Atlas passes behind the sun, completely out of view from Earth. Loeb pointed to this as if the object were intentionally avoiding detection, and even suggested it could be a probe sent by an extraterrestrial civilization. Yet even Loeb himself admitted that it was far more likely to be a natural object, while emphasizing that we shouldn't dismiss other possibilities when faced with something so unusual. Most scientists say that despite its unusual trajectory, Atlas should be considered a natural object, unless clear evidence shows otherwise. What we must not overlook is this: Atlas is clearly a crucial clue for understanding the universe beyond our solar system. Recent orbital backtracking of Atlas suggests it came not from the Milky Way's thin disk, where our solar system resides, but from the much older thick disk. The thin disk contains relatively young, metal-rich stars, much like those in our solar system. By contrast, the thick disk is filled with ancient stars, often older than 9 billion years, far older than the sun. These stars have low metallicity and retain imprints of the galaxy's early history. Atlas's trajectory, speed, and metal composition all point to it being a fragment shed from that ancient galactic population. For as long as we've existed, humans have imagined and dreamed of the cosmos, and yet we may not leave this solar system for a long time, perhaps not ever. To date, only 2 human-made probes have crossed the boundary of our solar system, Voyager 1 and Voyager 2. But the number of objects entering the solar system from far beyond may be greater than we think. Even if the odds are extremely low, the sheer vastness of the universe can overwhelm those odds. According to estimates from interstellar research groups, there may be up to 10,000 interstellar objects currently in the solar system, with roughly 7 new ones arriving each year. Those fragments already hold countless traces of the wider universe all around us.